Hello everyone, welcome to this example recording on source transformation. So in this video we're going to be taking a look at the problem that's indicated, and the problem reads as follows. Use source transformation to convert the circuit below into its equivalent circuit on the right, which in this case would be the circuit that sits just below it. We need to find a way to convert the top circuit to the bottom circuit. So the first thing that we do is to take a look at what are the similarities between the two circuits. You'll notice that everything to the right of these terminal points is exactly identical. There's the 12, the 10, and the 5. So this tells us that we then need to simplify the whole circuit to the left of the red terminals and convert that to a current source and one resistor. Right, so let's begin with that. So what we would then do is, starting on the left hand side, we can convert the voltage source in series with a resistor to a current source in parallel with a resistor. And the value of the current source can then be calculated as the voltage divided by the resistance. Right. The current source will be 10 divided by 10, which gives you 1 amp. The resistance value will be 10 ohms. This current will be 5. And we convert the 10 and the 15 to 10 divided by 15 in terms of the current value, which gives you 0.67 amps and a value of 15 ohms. Right, and the circuit should continue, but we'll consider this part for now. Then we can add the 3 current sources to give you one current source with a value of 1 plus 5 plus 0.67. So let's give you a value of 6.67 amps. We can add the resistors, that's 10 in parallel with 15. So 10 in parallel with 15 gives you a value of 6 ohms. Right, and now we can connect this to the rest of the circuit, and the rest of the circuit had a resistor, and a current source of 15 amps. The resistor value was 5 and this resistor was 10, and we know that this is 6. Right, and this continues to the rest of the circuit, but this is what we're interested in. Now, to further simplify this, we'll then have to convert this current source in parallel with the resistor to a voltage source in series with the resistor, so that we can add all the series resistances together and then take it back to a current source in parallel with the resistor. So I convert this to a voltage source in series with the resistor. That's the series resistance. That will be connected with the 10 and with the 5, and the current source of 15, and that's 10, that's 5, and that's 6, and the value of the voltage source should be the 6.67 times 6. And that gives us a value of 40.02 volts. So we've got a value voltage of 40.02 volts. Now we can add all the resistors together. So we've got 6 plus 5 is 11 plus 10, which will be 21 ohms. And we then convert that to a current source in parallel with the 21 ohm resistor and the 15 amp current, and the value of that current should be the 40,02 divided by the 21 ohm resistance, and that will give us a value of 1,9 amps. So what's then left is to add the two current sources to give you one final current value in series with the resistance. The resistance is 21 ohms and the current will be 15 plus 1.9, which gives you 16,9 amps. Right, so the value of I is then equal to 16,9 amps and the value of R is equal to 21 ohms. Thank you for watching this video and enjoy the course.